Alright, today we're looking at hyperbolas. The first thing we want to do is look at their standard form. So we have two different standard forms, just like we did with an ellipse. Here we have where the x comes first, so we have x minus h squared over a squared minus. This is the big difference between a hyperbola and an ellipse. The ellipse has a plus in between, the hyperbola has a minus in between. So here is minus y minus k squared over b squared. This is going to be a horizontal hyperbola. The other way is now when y leads, we still have a squared first, that minus, and then x term comes second. This is going to be our vertical parabola. So to give you an idea of what these look like and how you'll graph it, the first thing you'll do is you'll draw your graph. You're going to plot your center. Again, the center comes from the top here. I'm just going to make it be at 0, 0, just to get an idea. Under x, you'll take the square root of that number, and that's going to tell you left and right. So it's going to start off exactly as it did before. So here we go left and right. Whichever one comes first will always be your vertices. Here it doesn't matter if it's bigger or smaller, the first number will always be your vertices. That positive term that comes before the minus sign, that one will always be your vertices. So it may end up being that it's longer, taller than it is wide, even though x comes first. So I'm going to draw this one kind of backwards so you get the idea. Here, then if we have y, you'll take the square root of that number. That'll tell you up and down. So let's pretend like it goes up even higher than it is wide. These would be our covertices. Then what you're going to do is you're going to draw a rectangle that connects all of those points. So you'll go over and down, draw a rectangle that connects those points. Hyperbolas have asymptotes, so you're going to draw your asymptotes. We always use dashed lines for asymptotes. They go through the corners and the center. So you draw those out. Then you're going to draw your hyperbola out from your vertices. Now again, the vertices are always come first. So here my vertices are off the x, so we're going to draw our hyperbola, and it's going to go out as wide as those asymptotes. That's how you're going to know kind of the width, is those asymptotes are your guidelines, because your hyperbola come close to them but never actually touch them. And so that's what you're going to have for your hyperbola. A horizontal hyperbola a vertical hyperbola is very similar. You're going to do the same thing. You'll plot your center. Here, y comes first. You'll go up and down on the y-axis, however many points. I try to make those first points that I draw, whether they be vertical or horizontal, whichever ones come first, I try and draw them a little bit bigger, so that way I remember later on which ones are my vertices. Then you go out for your covertices. We'll make them over here. Again, you draw your box. So just to give you a guideline of where your asymptotes go. Idea of where your asymptotes, they go through the center and the corners of your box. And then whichever one came first, wherever you drew your fat dots, that's where your hyperbola comes out from. So here our hyperbola will go up and down. Just like on an ellipse, we're going to have foci here on our hyperbolas. So the foci, the formula we use for hyperbolas is c squared equals a squared plus b squared. So this actually is your Pythagorean theorem. But notice the equation has a minus sign. My foci equation has a plus sign. They're always going to be opposite of each other. Do you remember ellipses? The equation, the standard form of the equation was a plus here, and the foci equation was a minus, so they're opposite signs. And again, they're on the same axis as the vertices. Okay, so on this one, our foci, they're going to be inside the hyperbola, which is outside of your box. They'd be along that axis. This one, they'd be along your vertical axis. So let's go ahead and do an example so that way we know. And let's one more time write down here, vertices come first. Every single solitary time, that first term is going to be, that positive term is going to be where your vertices come from. Okay, so if we look at an example, so if I give you an example of y minus 1 squared over 64 minus x plus 2 squared over 4 equals 1. Again, these always equal 1, just like they did in an ellipse. We want to go ahead, and the first thing we want to do is plot our center. Remember, your center goes x comma y. So here our center is going to be -2, +1. So we'll go to -2, +1, and plot our center. Okay, we're going to go left and right is the square root of the number under x, up and down is the square root of number under y. I'm going to start with my y because it comes first, so we're going to go up and down 8 units. So from my vertex, we're going to go up 8 units. I'm going to make these fatter dots, and down 8 units. Okay, and those will be my vertices. And then we're going to go 2 to the left and right from my center. So 2 to the left, 2 to the right, or I guess that was right then left. Okay, so we've got those points plotted. Now we want to draw a rectangle using those points. So we started our vertices. It goes down this y-axis, across, and up through that point. Now we want to draw on our asymptotes. They go through the corners and that center. So I kind of draw from the center up to the corner, center down to the corner, down to the corner, oops, I missed, up to the corner. Okay, and then, so our vertices, our asymptotes go through the center, up through the corners. Now we want to draw the hyperbola through the vertices. Remember, the vertices always come first. We drew them as fatter dots, so we would remember. We're going to go up with our hyperbola, again because y came first, and down with our hyperbola. And there you have your beautiful graph. As you draw these on paper with a pencil, you'll do that rectangle box a little bit softer, so that way the things that stand out are those asymptotes and the hyperbola itself. Last thing we want to do is find and label our foci. I'm going to switch colors for this. So our foci are at c squared equals a squared plus b squared. Again, a squared and b squared are your denominators. So we're going to say c squared equals 64 plus 4. C squared equals 68, so C equals the square root of 68. If you were to write these points out, we're going to do it just like we did before. So if we write out our foci, because they're going up and down, because this is a vertical hyperbola, they'd be at the coordinate points -2, comma, we're changing the y value because they go up and down 1 plus or minus the square root of 68. The square root of 68 is a little bit more than 8, it's 8 point some change. So from our center, we'll go up 8 point something. Get there as close as I can, and down 8 point something. And put that foci in there.